Hello, Algebra 2. We are recording and we are watching the 7.2 notes video. You'll notice that this video is on Canvas as opposed to item pool. I was just experiencing, you guys were experiencing some glitches and it was becoming more of a headache than it was worth, so I figured out a way to do it through Canvas. Canvas has its own kinks a little bit on my end that item pool doesn't have, but I think we'll all come out winning here in this in the end here by using Canvas. So hopefully this works out for you. So we're jumping into the 7.2 notes, and you recall factoring, guys. I said it a lot last semester that factoring is going to be a big deal. Factoring is going to be a big deal. Factoring continues to be a big deal. It's a big deal. It's a big deal. It's a big deal. And I wasn't kidding. And it's a pretty big deal for this lesson. And if you have forgotten, you're gonna want to, and you're gonna need to go back and watch some videos. Okay. So on my YouTube channel, there are two videos. There's the first one, the Algebra 2 Lesson 2.2, where it was first introduced. And then in Lesson 2.3, at the beginning of the notes, you can see here, if you can read that, it says review a previous lesson. I did a little mini review right there. I'm going to do my best to jog your memory, but this video would be infinitely long, practically, if I tried to reteach you factoring and teach you like the new concept here. You know what I'm saying? So I'm going to do my best to keep it short and not drone on too much about old stuff. So I highly recommend these videos. Okay. So let's jump back into the notes here. So factoring. The big thing about factoring was, well, the initial concept that I said is that we're looking for two numbers that multiply to 40 and add to 13. The answer, 8 and 5. 8 times 5 is 40. 8 plus 5 is 13. Boom, we factored it. Now, and I'm not trying to review too much here because I just told you to watch the video, but what I say is that if you can't find those two numbers very easily, or it seems confusing, or you just don't see it, you can't figure it out, we could do this. You remember that? I'm not going to sit here and do that right now. That's what both of those videos discuss. If you don't know where 8 and 5 are coming from and you want a method to solve, that's what this guy is, okay? Is this method going to take you longer? Yes, but will it get you the right answer? 100% of the time. All right, this guy was a difference of squares. This was a pattern that we saw. If there's no middle term, we know that it has to be x plus the square root, x minus the square root. Because 12x and negative 12x cancel, which is why there's no middle term. Okay? These guys I'm going to pause on. Let's pause for C and D, and let's start to jump into these examples. These are rational expressions, which we first introduced in class with the 7.1 notes. I defined it very naively as functions that have x in the denominator, which clearly these do, right? So these are rational expressions, and we want to simplify these rational expressions. Well, let's think of a really basic fraction like 2/4. How do you simplify that fraction, or how do you reduce that fraction? You would say, well, they're both divisible by 2, right? 2 is 2 times 1, and 4 is 2 times 2, so the 2's cancel, and we're left with a half, right? Well, we're thinking, well, that's not an eraser. We're thinking something very similar here. We're thinking something very similar, except with these rational expressions. We factor this up, and we say, well, wait a minute. This is 4 times x, right? X squared is x times x. And this right here, they both share an x, so we can factor out an x, and we're left with 2x plus 3, right? You see how these can be put back together, right? Hopefully that's coming back a little bit. So there's an x on top and bottom, here and here. And when you cancel those out, what are you left with? 4x over 2x plus 3. So we just simplified the expression. Now, there's a slight catch though. It says here to state any values for which the expression is undefined. So remember, when is something undefined? When is something undefined? We mentioned this in class. We can't divide by 0. Remember that, right? You can't divide by 0. So when I factor this up, when I look at this denominator and we look at this factoring job here, when is this equal to 0? Well, there's two factors. One here and one here. So the denominator is equal to 0 on two separate occasions, for x equals 0 and -3/2. Okay? So those are the undefined values. Even though we canceled out this x, we still say that it's undefined for 0, despite the fact that we canceled it out. Okay? So there were two things that happened here. Let's do a quick summary before I do the next example. We factored it up. We canceled out what could cancel, hence the word simplifying. And then we figured out the undefined values. How? By looking at the denominator and figuring out what makes it 0. Okay? Let's do it again. So we factor the top and bottom. You can use the little trick with the u's, right? Or, again, the question that you ask yourself is, what multiplies to -15 and adds to -2? The answer is -5 and +3. -5 times 3 is -15, and -5 plus 3 is -2. And then, what's that? What multiplies to -5 and adds to -4? That's x minus 5, x plus 1. -5 times 1 is -5, and -5 plus 1 is -4. Do you see a factor that's in common? I do, right? I would think you see it, right? Boom, that cancels out. And we're left with x plus 3 over x plus 1. So this is the simplified form because we were able to cancel out that factor. However, when it comes to the undefined values, you look at the original denominator. Don't forget that. First of all, right, -1 doesn't work, right? That's even in our final answer. But you don't just look at the final answer. You look at the original expression. You can't plug in -1, and you can't plug in 5. 5 minus 5 is 0, and -1 plus 1 is 0. Both no-nos, okay? Both make the denominator 0, which means the function is undefined. If I'm speaking a little too quickly because I feel like I'm speaking quickly, feel free to slow me down or to go back and rewatch it. Okay, so how about we have our first question. How do you factor this top term? Remember, you're looking for two numbers that multiply to -8 and add to -2. What are those magical two numbers? And you answer. Okay, you hopefully answered -4 and +2. -4 times 2 is -8, and -4 plus 2 is -2. Let's have a back-to-back question. Boom. Back-to-back question. What does that factor into? What multiplies to -4 and adds to 3? Okay, you just answered it. You told me the answer was +4 and -1. 4 times -1 is -4, and 4 minus 1 is indeed 3. Do you see a factor that's the same? Yes, indeedy, right? Oh, actually, no, I don't. I don't. For a second, I thought we had the 4's canceling, but nothing canceled. Nothing canceled. They wanted us to think, they being, I guess, me, right? The author of the question, although I didn't write all of these, so it wasn't me, but we wanted to be tempted, but guess what? Don't be tempted. Those factors aren't the same. So it's already its most simplified form. It's already in its most simplified form. However, there are still undefined values. It can't equal -4, and it can't equal 1. -4 plus 4 is 0. 1 minus 1 is 0. Let's keep it going. We factor it one more time. What multiplies to 6 and adds to 5? 3 and 2. Again, if at any point you're like, how in the world is he getting these so quickly? I'm just doing it in my head. Genuinely. I'm just thinking, what are the numbers that multiply to 6? 1 and 6, 2 and 3, 3 and 2, right? There's not a lot of combinations. And I'm thinking to myself, how do they add up to 5? But if you want a process to getting those numbers, again, I encourage you to go back and look at the videos that we've already done, where I've done like a whole bunch of examples using that U method as I've referred to it, okay? What's the GCF of these two terms? They both have not just one, but two x's. So you yank out an x squared and you're left with x plus 3. I hope you can see how that gets put back together. What's the difference between this and this? There's only two terms, and they both have x's, right? So it's not the same pattern, right? There's just simply a GCF, as we call it. All right, so what do they have in common? The x plus 3. And we're left with x plus 2 over x squared. Some students are tempted to... Oops, I didn't mean to hit that record button. Some students are tempted to... are tempted to want to cancel out these x's. Don't do that, right? It has to be an identical factor, right? If putting them in parentheses reinforces that, then fine. Are those things exactly the same? No, so they don't cancel. These are, so they do cancel. All right, let's have another question. What are the undefined values? What are the undefined values? X can't equal what or what? Okay, what you should have done is looked at the denominator and you said, okay, this can't be 0 and this can't be 0, right? That's the whole point. So what are the two magic numbers there? X can't be 0 or -3. All right. Neither of those is very good because we get a denominator of 0. All right, so now we're in this moment here where all of a sudden we have more going on. We have this A value that is bigger than 1. All right, and that pattern is not the whole, what multiplies to the last term and adds to the middle term isn't as foolproof, okay? You can still use the U method on this, and I show that in the video. I'm trying to, there were so many methods that I've shown in hopes that one of them would click for you. So maybe I do one of these with the U method and one of these without the U method, and I'll show you what's up, okay? So for this guy, let's use the U method for the first one. So 2x squared plus 9x minus 35. The U method, I say, you need to make a 1. So divide it by 0, or divide it by 2, sorry, and we get x squared plus 9 halves x minus 35 halves. Okay? And then we say b over 2 minus u, b over 2 plus u equals c. So what is half of 9 halves? The answer, 9/4. And then you multiply these two things together. And then you solve for u. Whoops, made a mistake there. Oh, wait a minute. I don't need to multiply by 2 over 2. I need to multiply by 8. Holy cow. Right? I need a common denominator of 16. So if I multiply by 8, that's a lot different than multiplying by 2. What is 35 times 8? 280. $81 minus 280, what is that? 199? That can't be right. Now I'm making a mistake in the video. I'm going to pause my recording right here. Okay, I figured out my error. So that way you guys didn't have to suffer watching me figure out the error. It's because I forgot the negative right here. Equals negative 35 halves. So I'm actually adding it over, and I'm actually adding 280. And I end up with 361 over 16, which equals u squared. And when I take the square root of 361 is 19, and square root of 16 is 4. Now, what's the significance of that? I plug in those numbers into this guy, into these. So 9/4 minus 19/4 equals negative 10/4, which is divide each by 2. We end up with negative 5 halves, and then 9/4 plus u. So we end up with 27/4. And then, so that looks kind of gross, right? We end up with x minus 5 halves, and then x plus 27/4. I'm going to pause again to make sure I know how to say this. Okay, this is kind of weird. I thought I pressed play, but I didn't, and so I was just paused. I think I left off here. I'm sorry if I left off in a different spot. I'm sorry. This becomes 28 divided by 4, which is 7. And when I write my two factors, they look like this. Okay? Well, and here's the thing. We divided away a 2 at the beginning of the problem. We need to multiply it back in, because that was like kind of illegal. It was just a trick to make it easier for us, but the 2 is still there, right? You can't just divide it away because you feel like it, right? It's still there. So when you multiply it back in, you end up with 2x minus 5, because the 2's cancel, times x plus 7. So this just factored into 2x minus 5 times x plus 7. That might feel like a lot, and I would agree, it kind of is a lot. But you will be able to skip steps. There are steps in here that I don't particularly feel the need to do, and I hope through repetition you feel that you don't need to do them as well. We have seen a decent amount of problems like this. We really have, because we had a whole unit on factoring. That's like all we did for like the 3 weeks straight. 3.5 weeks straight, maybe. So I just encourage you to go back. I encourage you to go back to the YouTube videos, to go back to your notes that you've written. Just go back. I want to show you another trick, and I might have shown you this already. Another method, I shouldn't say trick, another method to factoring these. So, split the middle term. I think I taught this, right? You'll let me know. So 6 times, to split the middle term, you do the front times the back. So what's the front times the back? 6 times negative 5 is negative 30. So then you ask yourself, what two numbers that multiply to negative 30 and add up to the middle number, negative 13? The answer? Negative 10 and, or no, it's not. Negative 15 and 2. Negative 15 times 2 is negative 30, and negative 15 plus 2 is negative 13. So you take those two magical numbers, negative 15 and 2x, and you split the middle term with them. You see that? We just took this negative 13x and split it into 2. And then what do? We look at the first two, and we look at the last two. And we look at the first two, and we say, is there a GCF? Is there a GCF there? 6 and 15 are both divisible by 3. And x squared and x, they both have an x. And we're left with 2x minus 5. And then you look at the next two terms and you say, do they have a GCF? You might look at that and say no, but there's always a GCF. The answer, oops, I wrote 3. Oh no, that's right. The answer is 1. The GCF is 1. Sorry. So you take the two outside terms and they become one factor, and you take the two matching terms and they become the other factor. Now, that definitely took up less space, but it's a little more mental brain power, right? You have to be able to come up with these two numbers. You have to be able to factor and find those GCFs. It's a lot more mental than it is some like rigorous set of steps, right? If you follow these steps to a T, you will get the answer. But if you got some mental math skills, this might be more your style. This is more my style. But I've had several of you, and by several I'm more than several. I've had a decent handful of you say that you appreciate the U method, that you like that there is a method to the madness. And you know, if that's your style, I mean, keep doing it. Keep doing it, right? So when I factored this, it becomes 3x plus 1 times 2x minus 5. So they both share an x minus 5. Bye-bye. And we're left with x plus 7 over 3x plus 1. And don't forget the undefined values. I guess I'll look at this, right? This is the denominator. So what are the undefined values? Whatever makes the denominator 0. Right? Whatever makes the denominator 0. Definitely a little bit longer of a problem. It is what it is. What can I say? All right. So you can see that there's a few more examples, but just for the sake of time, let's not like do all of them, and maybe we do a few in class as well. Let's do one more where it definitely looks messy. Always look for a GCF. I guess I kind of forgot to say that here, right? 2, 9, and 35, they don't have a GCF. 6, 13, and 5, they don't have a GCF. But take a look at this. 3, 18, and negative 48 are all divisible by 3. So we can just factor out a 3 at the very, very start of everything, right? And now this is a lot easier to factor than this. How about another question, just to make sure you're still watching and you're still with me? What does it factor into? What does it factor into? Whoops, that's still a highlighter. It's x blah times x blah. What is it? All right, you did it. I guess I'll stay purple. Jeez. What multiplies the negative 18 and adds to negative 6? The answer is well, I got to think about this for a second. The answer is Am I blanking? Oh, this is 16. This is 16. That's my bad. Okay, I guess we won't have a question there. You probably So what multiplies to... Okay, let's have a question now. Okay, so what did you just end up answering this time around? Jeez, I'm all over the place. What multiplies the negative 16 and adds the negative 6? That's negative 8 and positive 2. Then you look at the next one. Is there a GCF there? Those are both divisible. Those are all three are divisible by 3. Are they divisible by anything else? I think there's a bigger number there. 12 is divisible by 6, and so is 48. 48 is 6 times 8. Is 90 divisible by 6? Let me check a calculator. Yeah, 90 is divisible by 6. It's 15. So we can yank a 6 out of each of these. Let's change colors. We can yank a 6. And we're left with 2x squared minus 15 minus 8. So we can yank that 6 out. Nice, right? And now this is a little bit easier to factor. You know, get rid of those big numbers. Which method did you like? The more mental mathy or the U method? It's up to you. I personally like the more mental mathy thing, so that's what I'm going to do. Splitting the middle term. You do the front times the back, so let's just off to the side here, factor this up. Okay, there's an X here that I forgot. Let's factor this up. Front times the back, we end up with negative 16. So what are two numbers that multiply to negative 16 and add to negative 15? The answer, negative 16 and 1. That one's pretty easy, actually. Right, kind of obvious. I mean, I think. So then you look at the first two and you look at the second two. What's the GCF of the first two terms? They both have x, and they're both divisible by 2. And we end up with x minus 8 there then. Remember, you should always be able to put it back together if you ever needed to. What's the GCF of the second two terms? They're both divisible by 1. So another situation where it's just simply a 1, and we're left with 2x plus 1 and x minus 8. So when we go ahead and write this out, we end up with 2x plus 1 and x minus 8. So would you look at that? The x minus 8 cancels. And we're left with 3 times x plus 2 over 6 times 2x plus 1. I'm not quite done, right? Did you forget about the 3 and the 6? Because if you did, you're going to get the wrong answer, right? That factor cancels out, x minus 8 and x minus 8. But guess what? 3 over 6, that reduces down to a half. So that just cancels out. That just becomes a 1, but I'm not going to bother writing it, right? So that just goes away, and that is a 2 downstairs there. That is our final factored form. And how about I ask you one more time here? Take a look at this denominator. What are the two undefined terms? Give it a shot. All right, so the question popped up. You gave it a shot. What are the two undefined terms? You subtract that 1, you divide that 2. Can't be negative 1/2. And you add that 8 over. It can't be 8. Those two numbers make the denominator 0, and the function is undefined if the denominator is 0. All right. Under the 30-minute mark, we've got a couple of good questions there. So, yeah. I encourage, if you're still watching and you're like, okay, what else is he going to say? I encourage you to go back and watch those factoring videos. If factoring, because we did a lot of factoring here. And if that's just over your head, you got to go back, right? You got to go back and check those out. Check out the notes, check out the videos, and all that jazz, right? And all that jazz, okay? So, I bid you adieu.